Okay, so now we're going to work on the screw. So we're going to have 6 screws that we're going to make with our part families. So we'll start with making our master model, our main screw. We'll add in all our expressions. We will create the screw, and then we'll look at the part families. So in NX, we want to start with a model. We're going to be in inches. This is going to be the main model. I've named it the master model. You can just say main screw, whatever you want to name this to identify this as the file that contains the part family information. So remember, when we create the part families, we can't go into the child file and edit it. We have to go to the main model, the one that we actually used to create the part family, to make changes. So it's good to identify that. Make sure that you're saving this to a specific folder, because remember, we're going to have, once we're done, we're going to have multiple files that we're going to be saving these to. So it's a good idea to make a separate folder. So we'll say OK. And we'll start by creating expressions for all of the values or features that are going to change or that we want to have control over. So we'll go ahead and add expressions for all of those. And when we create our first screw, so the screw for the master model, this is not a screw that's actually going to be used. This is just one that contains all of the available features, essentially. So you'll notice on here that there is not a screw that contains a hole for the locking wire and the vent. So there's not a screw that says yes on both of these. But on the screw that we make for the master model, we will have both holes. So the master model contains essentially all available features, and then we can select which ones we want or what sizes we want from that. So these are the 6 parts that we actually want, but the master model will contain all of the available features. So back in NX, I will hit Control E to pull up the expressions. And I'm going to populate the expressions that are shown on canvas. Now the values I'm going to use for each of these expressions are just based off of screw 1 on our list. But remember that these values are kind of meaningless. Like this master model screw is not one that's actually going to be used. It's just going to be the one that has all the features. So the values don't really matter, but we're just going to go off the values for screw 1, except for the locking wire, which there is none on screw 1, but we'll add one in and give it a value. So let's go ahead and populate our expressions. All right, there's all of our expressions and the values. I'll say OK. And we can go ahead and start modeling the screw. Start with a sketch. On the top plane. And we'll go to more. We want to do a polygon. 6 sides. Center point starting at the origin. And we'll go ahead and add a constraint on here for one of the axes. I'll do my vertical axis, so it's going to make coincident with the vertical axis here. Close out of that. And we'll go ahead and define the head width. The width is going to be from flat to flat. Doesn't matter which one you select. I will choose the top and bottom here. And the value that we're going to put in is not an actual value. We want to relate this to the expression that we just made for the head width. So you can type it in here, but what I like to do is right click on our dimension, add/remove expression. And now when we start typing in, it's going to pop up from our available list of expressions. So head height, head width. Well, this is going to be our head width. So we'll say OK. I'm going to decrease this font a little bit. Make it look a little bit nicer. So that's our head width. Sketch is fully defined. We'll say finish. And we can go ahead and extrude this. I'm going to change the direction. I wanted this extruding down. The end distance is going to be our head height. And we work on the shaft of the screw. So we'll make another sketch. I'm going to sketch on this bottom surface of the bolt. You could do the top. It really doesn't matter. I'll say OK. And I want to do a circle. Just going to make it somewhere on the bolt. And I want to constrain this so that the center, the arc center, is coincident with our sketch origin, or our datum origin here. So I'll go to create persistent relations, make coincident, pick up that arc center, and then I'm going to change my scope so that I am selecting the datum coordinate system origin there. The diameter for this is going to be 1/2 inch. Now we're hard coding in a value here because all of our bolts are going to be 1/2 inch 13. So this is never going to change for these bolts. If it would change, we would have to make this an actual expression and make it where we can change the value, but we don't have to do that, so we're not going to. Now our sketch is fully defined. We'll say finish. And we're going to extrude this. Make sure that we are extruding away from the head. And it is picked up the last value that we put in, which is the head height. This is not what we want. So I'm going to click on the equal sign here for the formula. I'll go to make constant, and now I can just type in the value that we want. This is going to be our screw length. I want the screw length to be how far this cylinder is being extruded. The cylinder will be the shaft of the bolt. So we'll say, make sure that we have unite on our Boolean, and we'll say OK. All right, now before we throw the threads on, let's put a chamfer on the shaft diameter here. So we'll come to chamfer. And I don't want a symmetric chamfer like we usually do. I'm going to change this to offset and angle because I don't want a 45-degree angle. I want a 30. I'm going to change this to 30. And the distance that I'm going to use is 0.06. So offset and angle, distance of 0.06 at an angle of 30 degrees. And we're going to select this edge of our bolt. I'll say OK. Now we can put a thread on this, and we are going to use external threads, like our detailed threads. So I'm going to go to more, the thread tool. Make sure we have detailed threads. And the face I'm going to select is just the shaft of our bolt. It should pick up the 1/2 inch 13 based off of the diameter of the shaft. The limit here. So we do want value, okay? And we're going to go to make constant. I don't want to put in just a value of 1.25. I want this to be referencing the thread length. Okay. So we want to reference the thread length for our value. And we can say, okay. So here's basically our bolt, our screw. Let's look at the wire locking hole and then the vent hole, right? And then we'll be ready to go to our part families. So let's do the wire locking hole first. So we'll go to our hole tool. We just want a simple hole, custom, and the hole diameter that we're going to use is the wire hole diameter expression that we have, because this is going to change. Or we have two different values for this. No start or end chamfer on this. When we specify point, we're going to go to sketch section, and we just want to select one of our faces of, like one of the edge faces of our bolt. It does not matter which one we select. I'll select that one. And we just want our point to be centered on this face. So I'll just place it on the face. And I'll go to make midpoint aligned. I'll select the point. And then I'm going to select this line. And then I'm going to do it again to select the top line. So it doesn't matter which order you go in. So we'll select that. I'll say apply. This point and then this line. Remember, the make midpoint aligned aligns the point to the middle of our line. So it's sort of like horizontally and vertically aligning the midpoints together. So it's going to position that on that face. And this way, if the head size changes, this will be centrally located all the time. That's what we want. Sketch is fully defined. We'll say finish. So this is going to be so the depth limit, this is going to be a through body. And we'll say okay. And now for the vent hole, so we'll go to our hole tool again. Still simple, still custom. We only have one size for this. So there's only one diameter that we're ever going to use. So that's going to be 0.125. So this doesn't need to be expression because it's never going to change. Just like the 1/2 inch diameter is never going to change. So we'll say enter. So we'll go to sketch section on the top of our bolt head. And we just want to place our point at the origin of our datum coordinate system. I can do a make coincident and just make sure that I have a point there. We'll say finish. It's still through body. We'll say okay. So our main screw should look like this. Let's save this, and then let's go to our part families. So again, that's tools, and then part families. We're going to create a part family. And I'm going to go down to settings and make sure that we change the family save directory to the folder that we have set up to save all these parts to. So make sure that we change this folder. And we can go to our expressions here, or the available expressions. And we can start adding in what we want to change for each of our parts. So looks like screw length is our first one. I'm just going based off of what we have here. Okay, I'm gonna try to match this. So screw length. So it doesn't really matter what order you go in, but this is matching up. So I've selected screw length. I can say add at end. Then we have our thread length. Okay. I can also double click on it to add it in. Then we have head width, head height. And then we have a question. Or we have a question here. wire locking. Now this is going to decide whether we actually suppress the feature or not. So if we have no on here, then the feature is not even going to be generated. It's going to be suppressed. If we have yes, then it's going to apply the correct diameter. So to do that, we're going to change the available columns here from expression to features. And this is essentially looking at our part navigator. In fact, if you look at my screen, it's essentially matching up with everything that we have on the part navigator. Now, if you had a whole bunch of holes or you had a whole bunch going on, it probably makes sense to name these. That way you can remember which one is which, okay? So if you want to do that, you can. I'm going to move on though. So there's a 0.109 hole. This is for our wire locking hole. So I can select this and I can insert that. And notice that it's just a yes or no question, right? So this is yes or no. Do you want me to generate this? If we go back to expressions, I can add in the wire hole diameter. So now it's, do you want me to generate this? Yes or no? If yes, then it's going to apply this value. And last, we have the vent hole. Now, if we go back to features, we'll add in the 0.125 diameter hole. Add that in. We do not have an expression for this size because the size doesn't change. It's just, do you want NX to generate it or not? So we don't have any value that's going to change this. I'm going to go ahead and save this family so that it doesn't get deleted accidentally. And I'm going to go and I'm going to change the names on these holes so you can see what that looks like, okay? So I'll change the 0.109. I will say rename. So wire locking. And I'll rename this to vent. Now, if we go back to our part families, you'll see wire locking and vent, okay? So that might help you out a little bit. Now let's fill in the information that we have here. So this is going to be the information that we add into our table. So the part name, we're going to use the part name for the name and the number. So this will be for both columns. And then we don't have anything for our thread because that's the same for each one and everything should match up. So we're just going to copy this over and then look at how we view the file and save everything else like that. So this information that we're seeing here, this is the current values for our model here. But we're going to keep this model as a separate file altogether. So SO1 is not going to be this main model. So what I'm going to do is I'm just going to actually delete all these values here and start with our SO1 values. When you have a no, so wire locking is no, you still have to put a value here for the diameter, but you can just put 0. You just can't leave it blank. That's the only thing. And this one does have the vent hole. I'm going to go ahead and save it. If you see the blue text, that means that it's unsaved, so you haven't saved it. But once you just hit save family, it's going to save the information. This allows you to, exit out, right, and then come back and your information is all still there. You haven't created this part yet, but the information is stored. I'm going to go through and make the rest of these, and then we will see what the next step is. All right, so here's our completed list. Now let's say I wanted to test one of these. So let's, I'll look at SO3 because that's got the wire locking hole only. So I selected the whole entire row, and then you'll see these icons populate up here. So verify part is the one that we want. So verify part, what that's going to do is it's going to apply these values to our current part that we have, so to the master model. So none of these parts are actually made yet, right? So none of these have been created, but we can apply the values. So I'll highlight part 3. I can say verify part. And you'll see that we're still in, so this is still that master model screw that I made, but obviously this looks different. And so if you look here, it is suppressing the vent hole because we have that turned off. We have that as set to no, so it's actually suppressing that for us. And this is a good way to validate that, it's actually going to work correctly, right? But again, the part hasn't been made, so we can see here with this menu, this window, verify part. So we can just say close here. To actually make these parts, right, to actually make them, we need to actually select create parts. I'm going to select all of our parts, right, so all 6, and I can say create parts. And it's going to take it a second, and it has said the parts were created successfully. If there is an error, then it would populate here. Sometimes you can get an error where the part still is made, but something weird, maybe a sketch got messed up or something. But sometimes the part will actually not generate at all. That's when you have a big problem, and that would be a good time where you could say, okay, well, let's see what went wrong, and then you could go back to verify part and maybe see, what's not generating correctly. But everything generated correctly here, you can say okay. Now if we went to that folder, we can see that we now have, here's the master model and these 6 screws that we just made. Now it's important to remember that if you need to edit one of these, you have to go to the master model and edit the part there. So I have our part 1 open, and you can see that it's got the lock on here. It's read only. We can still use it in like assemblies and anything else, but I can't edit it here in this configuration. So maybe I wanted to change something about, sketch 3, right? It's going to say a read only object has been modified. You will not be able to save the changes to it. What we could technically do is edit this and then do a save as and save it as a completely different part. But it would have to be a different name and everything else. So it would be a completely different part. So anytime we need to make a change to one of our part family members, we have to go back to the master model here and change it in our table. For this assignment, though, all of that I'm asking of you is to a screenshot of this right here. So a quick way to do that is to use the snipping tool. You can search for it down the search bar. We're just going to make sure we have an image, and we'll say new. And we just want to make sure we have a screenshot of that, just like this, okay? So you don't have to create all of the members, but you do need to have a screenshot of the table that you created to theoretically create all 6 of these parts.